So today the event is end-to-end evaluation of RAG-based applications. So what does this include? Obviously there are many different aspects. We're going to focus here on the methodologies and best practices for evaluating RAG-based systems, which will be, covering a few different phases. So there are, of course, the very, very first experiments when you're approaching a POC, comparing different versions when you have, a few potential finalists. Sometimes we call them candidates, and also for ongoing evaluation and production. All these are generic aspects about LLM evaluation, which are always important. Today, there's going to be a bit more emphasis on our RAG use case, which is pretty common. So something that I think is pretty interesting, I know that there are many really useful and really important tools related to LLMs. The way we see the three most central ones are the model, VectorDB, and search, which you don't need for every use case, but typically a team building a few use cases will need at least one of them. And then we have the LLM evaluation. So LLM evaluation is becoming more essential now, now that a lot of companies or teams are passing from the POC phase to the phase of actually building a system that needs to work for end users in production, or sometimes it's not directly for the end user, but it's something that impacts the flow related to the end user. And for that, it's really critical to have LLM evaluation in place. So just as a kind of thought that definitely supports our company's thoughts about this, is there's no real such thing as a test set for generative AI. It's not that there's nothing that's remotely similar, but not in the same manner as the classic AI ML use cases. Because there's more than one correct answer when you're generating answers typically. And that means that if you're not exactly on the school solution or matching the school solution, that doesn't mean that whatever the answer contained was bad. So that's like a little nuance, but it changes really a lot of things of how we approach it. And you really need it at a pretty early on phase related when you're talking about LLMs. So at Deepchecks, we took an approach which we call the dual design. So there are a lot of times a team consists both of developers, AI ML folks, LLM practitioners that are related to that need to build the system, help be part of it. But you also might have folks like product managers, data curation, business analysts, and all these types of figures. They have a lot of times deeper, maybe even deeper knowledge about the domain that's related to the app that's now being built. And we really think that the collaboration, or getting to the point where there can be flows that are beneficial even without diving deep into the code, that's key. So a lot of what you'll see today from Noam and Shay is all sorts of automations and workflows that enable nailing that workflow. So just before we dive in, I want to talk about our next event. So in about a month, we'll be hosting an event together with NVIDIA, where we're focusing specifically on the aspects that are more related to risk or related to safety. I won't hog too much of the time for this one, just because today we're focusing on something that's a bit different. So, but feel free to sign up. It's already live on our LinkedIn, and it should be pretty easy to find. I'll also once Noam starts talking, I'll also send details in the chat. Anyway, Noam, you're up.
Oh, thanks, Philip. Just a second, let's all be involved. So, yeah, as Phil mentioned, throughout the last year of seeing how companies build and deploy LLM-based applications, and specifically RAG-based applications to production, it become pretty clear that evaluating these kind of systems is pretty different than evaluating classical machine learning models, and it's also quite harder. So I'll try to show you why we think that this is a hard new challenge, and how we approach this challenge of evaluating RAG-based systems at Deepchecks. And we'll finish by a demo that Shay will be giving, showing you how this approach comes into life in the Deepchecks LLM evaluation system. And so just before we start, a quick introduction. My name is Noam. I lead the R&D at Deepchecks, and been doing research for the past 10 years, initially in physics and later on data science. And presenting with me today is Shay Tsadok, Senior Software Engineer in Deepchecks, right here beside us, and been doing data engineering, MLOps, and backend and system architecture for the past 20 years. And so a lot of experience that they will be saying later. And so just to define the problem we'll be talking about.
Just one second. As Noam's starting, I'm going to be sending the first poll here. So we're talking about, currently we're going to be talking about in the poll, what's the stage of the current RAG application that you're working on? Of course, for some, it's just conceptualization and design. The next phase is development and testing. Category number 3 is production and deployment. And then optimization and scaling is the next one. So I'll leave that open, Noam, as you go, and I'll cut you off again shortly to present the results.
No problem. So just to define what we'll be talking about, of course, many applications for LLMs, various use cases, summarization, content creation, even the most famous use cases, coding aids, copilots, etc. But today we'll be focusing on a particular use case of RAG question answering, RAG standing for Retrieval Augmented Generation. And when we talk about Q&A RAG applications, we usually talk about the following structure. You have some kind of user posing questions to the system. The question is then passed to some kind of retrieval system, which means we search some kind of document store for documents that are most relevant for that question. We bring them up, and we pass the question alongside these documents into some kind of prompt template that we made for LLM, and then run an LLM over this prompt, with the goal of producing an answer for the question based on the documents that we retrieved. And over this pretty basic structure, there are many engineering considerations and tweaks you may be able to do. On the user question side, you may want to do some kind of intent detection, seeing what is a question, what type of question, what things are not questions, and maybe rephrasing the way the user asked the original question. On the RAG side, on the retrieval side, the quality of the documents you'll be getting depends a lot on the embeddings you'll be using to encode the different documents and the type of search you'll be using, just semantic search, hybrid search, etc. And you may want to apply some kind of re-ranking of the results you'll be getting from the document store. Finally, where a lot of the engineering happens is in the LLM code itself. Of course, the prompt engineering, building the prompts that you want. You may also want to format the output. You may perform several calls to LLM in several steps instead of just one call. And you may even use dynamic few shot, for example, which will be giving the LLM examples for several good questions and answers from the past to let it know what kind of answer you're looking for. And all these things are things that you can tweak, change, and build towards building a better RAG application.
Okay, now we're gonna share the results of the poll. So we had, what stage for the RAG application. So we have 38% here in conceptualization and design, which is, I think, the broadest term. It could be mean a few different things. Development and testing, 36%. Of course, that's the funnest phase and the most interesting phase. Production and deployment, 19%, and optimization and scaling, 7%. So let's continue with the talk, but I think this was pretty much aligned with what I would have imagined.
Yeah, and so given that you built your RAG application, the next thing you probably want to do, or at least should do, is evaluating your system, and like you should ask yourself, like how different is it from evaluating a classical ML system? And the common part where it's pretty similar is you want to build some kind of evaluation set that represents your production use case. You don't want to be vibe-based and just evaluate, look at a couple of samples and see if it's good enough. You want to build some kind of a set of potential user questions or inputs that represents the cases that you expect to encounter in production. So, for example, you want to represent different demographics of people asking the questions. A language would be one such example. Another one would be different topics. So in general, this talk will be like using an example of a medical QA, RAG QA bot, which you can ask it various questions about medical issues, about setting appointments, about bureaucratic parts. And as you can see, this bot can have several topics. You can ask about an illness, and you can also ask about the more technical parts of interfacing with the medical world. You may also have edge cases, so people may just ask input to your system stuff that is not related to the medical topics. It could be just using it as a Python ChatGPT like bot. And so you also want to include these edge cases in your evaluation set. So evaluation set aside, you saw it's already a bit different than building an evaluation set for a classical ML system. The next and the largest challenge is evaluating each sample. And that's where things start to get shaky. As Philip mentioned, you can't really use a ground truth here. Even if you have a ground truth, which means a good answer that you know that is good for a certain sample, it doesn't mean that there aren't other good answers that look completely different. Look at these examples. It's basically the same information here, and they're both good, but using traditional metrics such as rouge or blue, you won't be able to tell that these are the equivalent. You must evaluate them according to the criteria that you want them to have. The answers need to be correct. For example, they need to be polite, they need to meet other criteria, they need to be robust to all these edge cases. So you can't rely here on a certain set of ground truth annotations and just compare to them. You need to actually evaluate each output for all the criteria that you care about. And after you did that for each one of these samples, you can get an overall performance evaluation by aggregating the percent of good samples. And so before we move on to the main part, which is talking about what are the criteria that you should use and how you can enforce them, just a word about building a good evaluation set. And so again, you need to be representative. You need to be like not large, but not minuscule. So you can add in order to build your initial evaluation set, you can add manual questions that you or your analyst add to the system. You can also use LLMs to generate questions automatically by posing the types of questions and asking the LLM to expand using documents, for example. Once you have your initial set, you want to constantly update it with things you're seeing in production. Bad examples in which you see that your system is failing. Edge cases like we saw before. Things that are known that you need further annotation to decide if the answer was good or not, and different topics and characteristics of the questions. And you want to do that not once, but constantly, because your evaluation set needs to represent I'll say your performance on the evaluation set has to represent your performance in production, or it better should. And so given that you built this good and constantly updating,
no, just about that point of representing the production. So I am seeing different approaches from different companies where sometimes they say, okay, let's just take a random sample from production and that represents, right? But then I also do see where they say, okay, let's take those that are either a bit riskier or more important. You know, a customer that's paying might ask this more or so forth, and then kind of double down and like oversample them or so forth. So I think there are a few different approaches for how to make it represent not necessarily like the vanilla production, but like what I care about kind of in production.
Good point. You don't want to only statistically represent the sample, but also the parts that you care about.
Right. Yeah, but there are different approaches.
Yeah. And so, okay, let's talk about what you want to evaluate, and the things you want to evaluate go downstream for the ways in which rank systems can fail. So if we look at the level of the user input, you can have several failures right over there. So you can have the edge cases we saw before. We can also have jailbreaks, which are attempts to hack the system. On the retrieval level, you can have issues with the retrieval, missing documents, insufficient retrieval, or even issues with PII to give personal identifiable information. So to give some examples, I think some of you may be familiar with the DAN attack, in which you prompt the system into bypassing all the rules that you have carefully put in the system prompt. And for example, you can make the system give any prescription that you want. And it's kind of a joke example, but I think more serious cases that can happen. And also, you may, if you have data that, let's say, is not supposed to be the retrieval system, it can also get into the output. So, for example, if you didn't carefully check for that, you may be able to leak information about other people into a certain customer. And finally, I think the most common category of failures is failures on the level of the LLM when generating the final answer. And so there are many such failures. You may fail to answer the question completely, and you may have incorrect formatting. To give a couple examples, I think the most well-known one is hallucinations. It's a case in which the LLM is doing some kind of completion based on what it's learned in its training set, and that, let's say, in the case here with COVID, it may have read that somewhere. Maybe it read it in Reddit while training. But you don't want your LLM to complete based on the whole internet. You want your LLM to complete based on the documents you curated that you provided for it. So an hallucination in this definition, maybe anything that the LLM is adding that did not exist in your documents. And another example for failure, that's actually a real example that I got while preparing for this talk. Let's say I said the system, I need a dentist nearby. And the LLM says, here are 3 network dentists in your area accepting new patients. Full stop, end of answer. Where are these famous dentists? And funny enough, the LLM that I used to generate this example told me that's a good example, and I should show it in the example for good outputs. So this is a pretty common occurrence in which a crucial part of the answer is missing. And just as a mental framework, a way I like to think about these evaluation criteria is separating them from between guardrails against risk and quality criteria. When I talk about risks, the risks could be any case in which the LLM says something or the output contains something that is clearly and utterly bad. So that could be bias, it could be any kind of toxic output, could be any safety issue, for example, helping me prepare bioweapons or anything of that sort. It could be PII, as we shown earlier. Any of these are things that, if they exist, this sample should be marked as bad immediately. And we want to put some guardrails in place to protect against it.
By the way, a lot of times when we meet just people from the ecosystem, they might ask, is Deepchecks a company that deals with cybersecurity, or is it a company, is it a company, like each one of these is an independent question, or is it a company that deals with making sure that the LLM isn't saying something that could get you sued and so forth. And at some point we just realized, okay, it's a lot of the same workflows, and we just use the word risk. So risk kind of covers, I'd say, anything that's in the the long tail of the Gaussian, that things that won't necessarily happen pretty frequently, but when they do happen, then it's bad. And then I think, Noam will talk about the difference between risk and quality, but I think it's interesting. I don't think these are always all kind of grouped together, even when they are. Sometimes it's more academic, and here we're trying to bring that type of experience into the product.
Yeah, as Phil mentioned, risks are kind of a long tail phenomenon, and the fact that something passed your risk guardrails does not mean that the output is good. You still want to make sure that it's actually doing the thing that you asked it to do. So if you're talking about a RAG Q&A bot, you want it to fulfill the task. You want it to answer the question. You want it to answer the question in a logically correct manner. You want to avoid hallucinations, which, as I mentioned before, means actually using the information that you provided and not some other piece of information that it may have memorized. You want to have correct formatting and maybe follow some kind of guidelines. For example, a guideline would be, don't mention my competitor, or don't send people to my competitor. That's just one kind of example. So we have this risk, we have this quality criteria, and we want to make sure that they exist in our outputs. So looking at what people are doing, the most common method to evaluate if an answer produced by a RAG bot is good or not is human annotations, because that's the golden standard. And human annotations are, of course, excellent. If you build a good annotation team, they're excellent, they're explainable because they and a human can write the reasons down. This may be inconsistent, but that's could be overcome. But the main issue with them is that they're costly and they're time consuming, and you can't apply that at scale. So people have been coming up in the past year or so with the following solution, which is using LLMs as judges. The most basic form of that would be just asking an LLM to answer the question, is this answer a good answer to the input question? And maybe more complex forms of that, but the underlying reality of this kind of evaluation is the quality is not so high. Like these methods, as anyone who tried them can note, have their failure modes quite often, and they're very unexplainable. You may get an explanation out of the LLM. The LLM might write down an explanation, but the connection between that and the actual reason for it giving some kind of annotation is it's not really connected. Of course, LLMs are very inconsistent, way more so than humans if you run them several times over the same input. And it's complex to get a standardized method of evaluation from that. Finally, some cases you do have some kind of ground truth, some kind of golden answer for a given question. But as we mentioned, even if you happen to have that, that only helps you evaluate samples that are very similar to that answer. Because if something is very similar to the ground truth, then it's probably good. But otherwise, if it's not that similar, as I showed before, it may still be good. So it only covers a very small percent of the samples you may see in production, and it of course can't function well against guardrails and tail risks, because by definition you don't have them.
Right.
So, yeah.
Well, at the end of the slide, I have a question from
No.
as well.
Yeah. So in general, I was trying to what I was trying to get along is building an efficient evaluation pipeline is pretty hard for LLM applications. Yeah, Philip.
Yeah, so the question you have here, that also includes a +1 from Raymond, is how about GPT-4 as a judger for GPT-3?
So in general, what we wrote there applies pretty much to also to GPT-4. We found out that its quality as a judge as to distinguish if a given answer is good or not is not so good. Of course, it's way better. If you're doing that, I highly recommend using GPT-4, not GPT 3.5, but even the newer versions or Opus or any other of the GPT-4 level LLMs. But the fact that it's smarter than the LLM giving the answer does not mean it catches the more complex types of failures on its own. So from my experience, it doesn't really guarantee success.
All right, great. Okay, so before we move on to the next slide, so I'm launching the next survey, which is asking about LLM application evaluation. So the question is, how are you currently evaluating your LLM application? I know from before, at least some are still in conceptualization and design, so of course there'll be some not evaluating it. Then the options here are using open source LLM evaluation tools, using a third-party LLM evaluation SaaS, or using a homegrown solution. So Noam, I think you can proceed, and we'll talk a bit about we'll talk a bit about what the results are in a while. Let's start.
Cool. Yeah, Philip kept you hanging here on the cliff of the golden solution that we are about to propose, but essentially now the way we suggest to approach evaluating LLM-based application is what we call divide and conquer, or the multi-phased, multifaceted evaluation approach, which basically means in a more down-to-earth way that each of the criteria that we listed earlier, or at least the criteria that you care about, should be evaluated separately. You shouldn't be asking an LLM, for example, is this a good answer? You should be breaking down your criteria to success, both the quality criteria and the risk guardrails, into individual components and evaluate each one of them separately using the best tools for the task. So you have different tools for each one of these criteria. Once you have all of these, you can aggregate them and get a final evaluation of is that a good answer or not. And that has the benefits of being very high quality and compared to what we saw earlier, of course, not as high quality as a human, but potentially approaching that, and very explainable, because if something for some reason you get a good or bad annotation, you can see what criteria contributed to that annotation. And the criteria are by themselves explainable. So when I talk about selecting the right tool, I mean, not everything needs to be an LLM or needs to be a model. If you have very simple rules, for example, you want the JSON output to be valid and want the text to not be too long, you can use the classical method. You can use even regex, programmatic tools, anything like that. And once you approach the one level complexity higher.
Just quick note to the audience. We got a follow-up question from Shimon and from Max that are relating to the LLM as a judge. Don't worry, everyone. We'll get back to LLM as a judge. You'll see it in the demo. You'll see it in the multifaceted approach here. So don't worry. We'll get back to it.
Okay. And once you go one level of complexity higher, for example, you want to see if an answer is toxic or readable, or if a given answer is a relevant question, relevant answer to a given question, meaning it talks about the same issue. That's something you can do with classical NLP models. You can build tailor-made NLP models for these particular criteria and run them on each output. And that's things that classical NLP models are pretty good at. Once you approach criteria that are still narrow, but a bit more need more, let's say, reasoning power in order to evaluate, such as completeness, or meaning, is a given answer a complete answer that covers everything that the user was asking about? That's what we do think you want to use an LLM. But the key difference here is you're not asking the LLM to annotate if it's a good or bad answer. You're asking it a very well-defined, narrow question. Does this answer cover all the components in the user question? So we're not asking if it's correct. We're just asking if it talks about all the different things that the user was asking about. Or we can ask if it's polite. So we'll use an LLM as a judge, but we'll ask narrower questions that the LLM is more well-suited to answer, even talking about higher levels of LLMs. Finally, for the most complex level of criteria, for example, detecting hallucinations or evaluating if a retrieved document is actually a good document given the question, that's where we'll use the multi-step approaches, which essentially means breaking down the task into several steps. And I'll show an example for that right away. See if Philip has some kind of question before I move on.
I think you can move on. We have the same questions that we'll address in any case with the LLM.
So just to give an example what I mean by this spooky multi-step type evaluation. So let's say I want to evaluate what we call in Deepchecks retrieval relevance, which is essentially the question of, okay, so you retrieved some documents for the question. That's great, but are they actually relevant? Because it could be the case that there's no relevant document for that question in your database, and you're just giving the top stuff that is still garbage in, garbage out. And so some assumptions will assume that relevant is anything that addresses the subject of the question, and that a document could be relevant if only part of it is actually relevant for the question, because the answer could be hidden somewhere inside. So what we did here, we don't look at the document as a whole, but we split it into meaningful parts that contain key facts or claims about the world. And for each of these key facts or parts, we evaluate them for relevance compared to the question. So we'll do that in two levels. First, semantic, that does the meaning, the meaning of this document as a whole is close in semantic sense to the question. But we'll also look at the lexical level, at the word level. Do we see similar entities, people, places, dates, and times to what was mentioned in the question? Because we'll usually want to have both of them in order to define a chunk of document as relevant. We'll aggregate that across all the different components of the document, and we'll calculate the final score for the document. And we find that gives us a way better ability to distinguish, to rank documents for the relevance compared to just, semantic distance, or for just using, asking an LLM, is this relevant? We gain more power with this fine-grained resolution. So to wrap up, and before we address the questions from the crowd, we saw that rank can fail in many ways, and these ways are different and harder to evaluate in classical machine learning. tasks. And we talked about a bit how you can evaluate your system. First, you need to build a representative evaluation set. You need to select the criteria that you care about, both tail risks and quality criteria. And in order to evaluate, you want to use different approach and different tool for each one of your criteria and aggregate across them. So we'll soon see all of that in action in Shai's demo. And before that, I think, Philip, you had some questions for the crowd that we want to address before that.
Yeah, so one question is, what would pipeline integration look like? Is there any doc where I can see the supported integrations with Deepchecks evaluation? So I'll maybe say real quick here, if you go to docs.deepchecks.com or more directly to llmdocs.deepchecks.com, you should see a lot of this. I think the easiest thing to start off is the SDK quick start example there.
Yeah, you can also scan the QR code right here on the screen.
Oh, that's probably easier. Those are like QR codes. All right, a couple of other ones. So Max Schumacher, sorry if I got that wrong, it's a hard one, asked, how about a fuzzy ground truth, LLM judge plus text that contains the answer?
Yeah, that's essentially expanding across, trying to find similarity to existing existing ground truth answers. And I think you're right. That will work way better than using some kind of rouge or blue metric. But it still covers, I think, answers that are pretty equivalent to the original good answer. I think you'll find that it excludes answers that could be good in different ways, that are framed in a completely different way. And also, it doesn't cover all the way in which things can go haywire. So I think that would be the main point. You don't know in advance all the ways in which you can get a bad answer. And that's part of the reason you want guardrails and quality criteria in place.
All right, so there are a couple of other questions, but I'll try to answer what I can in the chat. Noam, I think you can also jump in and answer some of the last questions. I think let's move on to Shay in the meantime.
Sure. Shay, the stage is all yours.
Thank you all.
Wait, 1 second. Sorry, before that, I'll end the poll and share the results. So the question was, how are you currently evaluating your LLM applications? And then the answers were not evaluating yet. We got 33%, which does make sense. It's kind of in line with what we saw in the previous survey, using open source LLM evaluation tools, which definitely includes some of the known open sources. I think Ragas is a great example for that. Then there's using a third-party LLM evaluation SaaS, where that's just 2% now, which does make sense. I think some of these are a bit newer. And then also the 36% for using a homegrown solution. So it's not clear to me if homegrown solution includes reaching out to SaaSes like OpenAI, which I think that's probably pretty common. But then also maybe some of those that are using the open source LLM, maybe they're using one component but putting within a homegrown. Anyway, I know the question kind of forced to make like a binary decision, but anyway, I think it gives at least some feel for where everyone is. And yeah, I think we have something exciting. We'll talk about how easy it is to work with Deepchecks now. Just give a quick hint. We're adding now an option for pay-as-you-go, which is supposed to be pretty similar to working with an open source, at least in terms of scalability, pricing, investment within the solution, and so forth. So I'm stopping to share, and Shay, you're up.
Yes, so thank you. And now, welcome to the demo part. So I'm going to walk you through our system and show you how we can achieve most of the things that Noam talked about. What did you see here is the dashboard of our system. You can see that the application is GVHD demo. GVHD is a kind of data set that contains a disease that relate to transplantation. And here we are observing version number 2. We also have the baseline version. Now, so I think that, like as Noah mentioned, and most of you know that already, one of the hard part of the LLM application is actually the evaluation of the LLM application, and it's even harder when you talk about rapid changes that you want to apply to your application. Manually, it's very costly. LLM is just, it's not always the good solution. And now I'm going to present you how we are doing it in Deepchecks. So in Deepchecks, we use properties as a way to evaluate small parts of the interaction. And for each property, we choose the right tool to do that. So here, for instance, you see that in the data set, we have 77 interactions. And here you can see the properties that we extracted out of those interactions. So, for instance, we have RAG-related properties like relevance, which check the relation between the answer and the question. We have retrieval relevance, which check the relation between the information retrieval and the question. And we have the grounded in context, which checks the relation between the output and the information retrieval, and eventually find out if there is any hallucination in the answer. What that we are doing with all of those properties, we build set of rules that takes all of those properties and aggregate them into a single annotation per interaction. So we can see here the Deepchecks evaluate the data set. 40 out of those 77 interactions were marked as good, and 16 were marked as bad. And this give you like the overall score of that specific version in the application. Another thing that you can do is using the versions tab. Here you can see that we have two versions in the application, the last one and the baseline, the previous version. And you can.
Is it worth mentioning what a version is? Like if you change the prompt, that's a new version. If you add, change the custom code before or after, that's a new version. If you, do fine tuning, it's not that common yet from what we're seeing, but when you do that, then each model is a different version. So any change you make can be another line here. Usually there are a lot more rows than this, but it's good to demonstrate.
Right. So the version, as Philip mentioned, can be a prompt change, can be a model change, can be even something that you change in the way that you retrieve the data. Any one of them, it can be even a very simple change in the prompt. Any one of them is a different version that you might want to run the data set that you created, the test data set that Noam talked about, and then you can feed all of that data to Deepchecks to make the evaluation on. So here you can see that the baseline got a score of 82%. 82% of the interactions were marked as good, and only 71% of the interactions were marked as bad in the new version. What that you can do next is to dive into specific examples, because now we want to understand why some of the interactions were marked as bad. So here we are passed to the data tab where we can see all of the interactions. I ordered the interactions according to bad annotations. And now you can see the exact reasoning, what Noam thought about the explainability that we get when we are using properties. Now you can see it in front of your eyes. For this example, we can see that the interaction was marked bad because the grounded in context was very low. It means that that example was there were hallucination in that example. Here we have a low relevance score. Let's dive into it and we'll see why. The input was how does GVHD affect the skin, and the output was about the fact that there are two kinds of GVHD, which is not related to the input, and that's why we got the low score. Another thing that I want to show you is the ability to compare between the existing version and the previous version in the scope of interactions. So that you can also do from the version screen. I can choose to compare those two versions. And let's do it according to retrieval relevance, for instance. What the Deepchecks, what we are doing for you is popping up the same interaction. So those are the same interactions cross versions, but obviously you see that there were a few changes between the interactions. So these are the interactions have the same input. That's why it's the same interaction. And what we can see here that ointments is something that was existing in the information retrieval from the baseline version, but it was not exist in the information retrieval of the new version. And that's why the retrieval relevance score was low, and that's why we estimate that interaction as bad. So just a small recap for what we did so far. We went through the process of evaluation of a new version. We saw that Deepchecks know to extract properties, and using those properties to estimate in the interaction level to set if it's good or bad. And also we saw how you can use the system to dive into particular examples and to understand why the annotation was set to good or bad. The next thing you might wonder is, okay, we have a lot of various properties and capabilities that we have inside the system, but what if I want something else? What if I want to customize the application? So for that, we have few options. First of all, there is the simple option of supplying your own property. So if you have the ability to calculate property on your end, you can attach it to your data, upload to the system, and then you can use it like any other property that exists in the system. Also, you can define your own property with your own logic within Deepchecks application, within the Deepchecks system. I will show you how you can do that. So you can create a brand new property, and you can use something from the property bank that we supply. Let's say that in your organization.
By the way, just to clarify, the custom properties here is more flexible. You can do anything with it, right? It's their own code and so forth. But the LLM properties is a quick way to get something that's like what Shay showing is a quick way to use an LLM to quickly iterate with a new property. So it's a cool balance. A lot of times we'll see that that folks will be playing with LLM properties, trying stuff out for a couple of versions and so forth, and then thinking about it once it scales and you say, okay, I want less dependence on LLMs, or maybe have a more elegant way of doing it with custom code that's like, external snippet, metadata, whatever.
Right. For the custom property, we support both numeric and the categorical. And as Philip mentioned, the LLM property is more flexible. You can define your own logic inside and define an LLM way to evaluate something. So let's take, for example, let's say that in your organization, it is really important to check if the output is age appropriate or not. So for that, we have already a ready template to use. You can use that template. You can see on the left side the system message that we have. We can see that we asked the LLM to give a score between 1 and 5. 1 is the low score, 5 the high score, and those are the instructions for what we want to get from the LLM. What we see in the middle is an interaction that we took from the data set, and we actually can test it and get the score immediately on screen together with some reasoning. You can change interaction and then test again. And you can make some modification to the system message, test again until you find with the result. Then you can save the property and then use it as any other property that we have in the system. Last thing that I want to show you about the way to customize the system is the annotation configuration. So as I said before, there are a bunch of rules that we set that depend on the properties or the properties that we talked about to set the annotation per interaction, if it's good or bad. You can easily change that configuration. So for instance, if you add a property and you want to use that in the estimate annotation flow, all that you need to do is to download the configuration from here. It's a YAML file which you can update and then upload it again. And from that point on, you can use that new configuration. You can even apply that new configuration on all previous data that you have so far in the system. Last thing that I want to show you is the way to upload data to the system. So you can do it from the UI. If you have like a CSV or Excel file, you can just upload it from your machine. Pretty simple. And we have more extend capability, which is to use our SDK. So we supply Python SDK and also REST API. If you're not from, if you want to use something which is not Python, and you can see this is pretty simple. Just those few code lines. All that you need to do is to supply the API key here, and then you can upload data to the system. From the SDK, you can do like you can download all the data with all of the goodies that Deepchecks supplied and use it internally in your system. You can annotate, re-annotate the interactions on a later phase, and so on. So that's what that is. I hope that you enjoyed the demo and find it useful. Feel free to ask any question that you have even later on after the webinar. And I hope you enjoyed it.
All
Back
right.
to you, Philip. Noam.
Yeah. So, all right. So I think I'll take control back for a second. And yeah, so all right, here we go. All right, so thank you so much, both Noam and Shay, for the presentation and the demo. And I think for those of you that know Deepchecks, maybe it was fun for you to see the progress and how there are some really cool and interesting features. For those of you that are new to Deepchecks, so it's you know, I think it's a perfect way to kind of see what we're doing without having to do this in one-on-one setting and so forth. So a bit about the LLM evaluation. It's a lot easier to start now than it was a short while ago. We actually didn't like publicly announce before now this direction. So in the past, we would say, okay, you know, try, we have a POC, free trial, you know, then we'll kind of see what it looks like. We're now adding pay as you go. Why is this interesting? We know that some folks are comparing this with open source, at least partially because of timing. A lot of times there's a project that's ongoing, and then you don't exactly know when it kind of makes sense. But then in the meantime, you might be able to build your infrastructure on your own, and you know, like there is some sort of like you know, game theory type thing happening, just in terms of when is a good time to start. So we're now enabling a method where you basically are paying per token. It's very similar to working with you know, with you know, another LLM. Like if you say, okay, I want to try Claude, or I want to try you know, like something new that happened, you know, Gemini. So very similarly, you're basically saying I'm going to be paying per number of tokens. And then you kind of scale and commit when it, you know, when it makes sense, or when you need something like an enterprise feature, on-premise deployment, et cetera. So typically, we're just, at least now, I'm not saying this will be the you know, we'll enable it forever, but when you say, okay, I just want to try it, and we'll basically say, okay, here's access, and then you get a few $100s in evaluation credits to get started. So it's not like a decision of, am I buying Deepchecks? It's much more like, okay, you know, here are the credits, let's start, let's play with it. Then even when you're working it, you could say, okay, I'm not using it for production, I'm using it just for version comparison at a low scale. So we try to do this to make the decision to at least kick the tires a bit easier, and hope that'll encourage kind of some discussions. If you'd like to have discussions, we're not the folks that are the hardest to find in the world. I think we make more noise than average. So you can reach out to me, Noam, or Shay on LinkedIn, also to some other folks at Deepchecks. And this is my personal mail if you want to send you know, any reach out, and would definitely be happy for discussions, either about a concrete collaboration, or just you know, about some thoughts and you know, ways to design the project, even when it's related not just LLM evaluation. In any case, I think that's it on my side, at least. Let's take a few last questions, and then we'll take it from there. All right, so yeah, so I see at least one more question about Noam from Shimon. Noam.
Yeah, maybe I can address it here live. So I'll repeat the question and the answer for people who didn't read on the chat. The question was, are we able to detect using retrieval relevance the case in which the correct document did not appear in the top results? And indeed, that's one of the most common cases for RAG failures, a case in which you do retrieval, the documents that you retrieve are not the ones that are actually contain the answer to the question, so you can't answer the question based on them. The LLM will generate some slop, basically based on the irrelevant documents. And as I said, the retrieval relevance property is pretty good in catching these kind of cases. And just to clarify for Shimon there, it's not that we know to find for you the correct document. If you like, you can see the integration. We don't integrate with the full vector DB. We just see what are the retrieve documents that you are using. But we are able to tell that the documents that you have in your hands right now don't contain information relevant for the question. So in these cases, the retrieval relevance will usually return a pretty low score, one that is usually beyond that, like lower than the threshold we see. We use to set bad annotations based on that.
All right. So I got a few compliments from folks in the chat. Really appreciate that. It was great having so many people from all around the world. We know that just to accommodate all the different time zones, we can never make it perfect for everyone. So really appreciate going the extra mile. And for those of you that are watching it, not in real time, but afterwards, also thank you for joining one way or another. Anyway, bye, and thanks again, Noam and Shay, for presenting. I'll do the virtual clapping for you as well. Bye, everyone.
Bye-bye.
Everyone.